before the technology gods interfered, we were going to do example 10. After restarting a couple of programs, we're back on track. Example 10 asks us to show that this series, summation from n equals 1 to infinity of 1 over n times n plus 1 is convergent and find its sum. Well, so far we've only done geometric series. I wonder if this thing is in fact geometric. Well, there's kind of a clue to show us that it's definitely not. And the reason why is because there's no powers, right? I don't have some sort of ratio that's being raised to a particular power. All right, so we're going to have to see what the heck we're going to have to do on this one. Okay, so what I'm gonna do is I'm gonna go ahead and just rewrite out this, like, terms of the sequence so we can kind of get a handle of maybe what's going on. So example 10, why do I have the highlighter? I don't know. Example the 10th, we have the summation. I think it starts at 1, right? Yeah, it's definitely not going to start at 0. All right. N equals 1 to infinity of 1 over n times n plus 1. All right, starting at 1, if I plug 1 in there, I have 1 over 1 times 2. Plus, if I stick in 2, I'd have 1 over 2 times 3. And you can see the pattern continuing here. 3 times 4. 4 times 5. Dot, dot, dot. 1 over n times n plus 1, and then you are supposed to continue it after that nth term. Yeah, so you can see definitely there isn't a common ratio between these terms. There's nothing that I can multiply these things by in order to get the same number, like if I multiply these things by that same ratio. It's not geometric. So I can't use the same technique. I can't use a little formula for it. I've got to figure out some other way. So notice that back up here, I've got a product in the denominator. I've got this fraction. It looks sort of similar to whenever we did partial fractions. I'm pretty sure that's not how you spell that word. Partial fractions. So that's what we're going to try. We're going to try some partial fraction decomposition on this thing. I've got 1 over n times n plus 1. Let's make the conjecture that that breaks down to some number over n plus some other number over n plus 1. And then if I multiply by the common denominator, I'm going to get the basic equation. 1 is equal to a times n plus 1 plus b times n. Super easy, super simple to do partial fraction decomposition on. We just got to figure out some convenient values for n. How about we let first n equals 0? If we let n equal 0, then of course this term is going to disappear and we can solve it for a. So if I let n equal 0, I have 1 is equal to a times 0 plus 1. That's just a. Very nice. All right, so that means we have our a value. Let's do the same thing. Why didn't I choose pink again? All right, we left it at pink. What do I have to choose for n, conveniently, to make the a disappear? I need a -1. So if I choose -1 from n value, I'm going to have 1 is equal to a times -1 plus 1. That'll be 0. It'll disappear. And b times -1. All right, so then that implies that b is equal to -1. And I got its answer. Okay, so now I'm going to rewrite some stuff here. I'm going to rewrite this summation, the original summation that we had, using these partial fractions here instead. So, pink again. Typical. From n equals 1 to infinity, 1 over n times n plus 1 is the same thing as the summation from n equals 1 to infinity. Now it's the eraser that's active. Of 1 over n minus 1 over n plus 1 whenever I put the terms together. Okay, so now what I'm going to do is I'm just going to rewrite the sum using this new partial fraction decomposition formula. So this is going to look like, if I were to plug in 1, I'd have 1 over 1 minus 1 over 2. There's our first term. Plus, let's plug in 2. I'd have 1 over 2 minus 1 over 2 plus 1, 3. Make that a better looking 3. Okay. Plus, okay, let's plug in 3. 1 over 3 minus 1 over, well, looks like it's just going to be 4. The next one would be 1 over 4 minus 1 over 5, dot, dot, dot. You get the picture, right? And then the nth one is going to be 1 over n. So if I look at this, if this is plugging in, let's see, come back over here. This is n equals 1. And this one was the n equals 2, and so on. So whenever I go to plug in, that will be 1 over n on that last one. Whoops. Minus a 1 over n plus 1. Right? Okay, so there's the nth term, I should say. So we're trying to sum up all of these things and then take the limit, because it's supposed to like keep on going and going after this. But here's the thing. Like, notice that if I just rearrange my parentheses, stuff cancels out. Like a whole bunch of stuff cancels out. Let me get rid of these here. And let me move my parentheses over. I'm going to do the associative property, if you remember that from algebra. And let's rearrange our parentheses like this. Let's put it around these two. Right? And let's put it around these two. And let's put it around these two. And then so on. Whatever that term's missing. And say this term and that term is missing. It would have in front of it a negative 1 over n in front of it as well. And I did that, of course, because we can see cancel, 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 cancel. And you're left with only the first one and the last one. The first one and the nth one. I've got equals 1 minus 1 over n plus 1. This is not the whole series. This is basically the nth partial sum. The nth partial sum. So if I wanted the whole series, of course I'm supposed to keep on going. So in order to get the sum of the series, I need to take the limit as n approaches infinity of 1 minus 1 over n plus 1. And that's equal to, if I were to plug in infinity, this term over here, of course, is going to go to 0. And I just get 1. The sum of this series is equal to 1. It converges, and it converges to 1. This particular kind of series is called a telescoping series. And the name refers to one of those collapsible telescopes, which looks like this, right? And it's called a telescoping or a collapsing series because all of the stuff that's in the middle, it collapsed, it all canceled out, leaving you with the beginning and the end, the first one and the last one. All right, now technically speaking, just a heads up, this is kind of an extension. It's a telescoping series, not going to be on the AP exam, just so you know.